Comes on everyone. Let's start off. There. So last class we have finished with the circular motion. Today we'll be starting a new chapter, work power energy. Other scams on. So this is another base chapter. Other scams on. And where are the rest? Yeah, let's start off. So before jumping into the definitions and all, let's talk a bit about. So when you say energy, exactly what are you talking about? This is something I always keep telling you, always there is a technical definition and always there's a definition for you to understand. So if someone asks you, what is energy? How do you define this? What do you guys think? Ability to do work. This is all school definitions again, but the thing is, then I'll ask you, what is work? So, like I keep saying, right? When I say define something, you need not have an exact definition. Even an example works. So, let me tell you something like this. Imagine 10,000 years back when you're a cave person, right? And you came out of your cave, and let's say there is a stone on top of a mountain, and there is a similar stone on the ground also. Now, you tell me which stone is more scary. Now, if you look at this person and ask him, boss, which stone is more scary? He will say A is more scary because he's scared that A might roll down the mountain and might hit him and might damage him. So now tell me one thing. Is he really scared of the stone? If he's really scared of the stone, shouldn't he be scared of stone B also? So what did he get scared of? He's not scared of the stone. He got scared of the position of the stone, isn't it? He got scared of the position of the stone. Similarly, let's say there's a water in a lake and there's a river which is flowing very fast. If you bring this cave person and show him, he will be comfortable going inside the lake, but he will feel scared to go into this river. So does he mean he's scared of the water? He's actually scared because he knows if he gets into the river will drag him out and that becomes a problem. So what is he actually getting scared of? He's not getting scared of the stone or the water. He's actually getting scared of this position or the height. He's getting scared of the velocity. So that means inherently, right? Even when you didn't have any terminology 10,000 years back, when you don't have language also, you understand a stone on a mountain has something more compared to a stone on the ground, right? And you also understand the water in a river has something more compared to a water in a lake. Now, what is that something? He doesn't have an idea. You're getting it? We definitely know the water in a river, which is flowing, has something more. It is different compared to a water in a lake, even though both are waters only. So from that terminology, right, we can define something like this. We can say an energy is simply a quantity. Now, what is that quantity? No idea. Something. So quantity possessed by a system due to its position. So this much you realize, like, depending on where you keep, this thing will possess more. So stone on a mountain possesses something more compared to stone on the ground. We call this thing potential energy. So somewhere down the line, you will create a terminology and we call it potential energy and kinetic energy, and due to its motion. So if something is moving, it has something called energy. Now, what is energy? That we don't know. We simply say anything that is moving has energy. Due to its motion, this is your kinetic energy. This is what the Q person will say. You're getting it? So same thing, if I ask you what is work, then what do you think is work? What do you think is work from this definition? So this is what I think about work. Again, remember, don't write these definitions in the exam. They'll cancel off. This is something which, I understand this way. Like I keep saying, there's always a technical definition. There's a definition for you to understand. So work is nothing but transfer of energy from one system to another system. So the process of transferring energy from one system to another is called work. So work is not energy. So when you think about energy, right, there is a very good analogy. Money is a pretty good similar to energy. You're getting it? So money is like energy. So when I take money and put it in my bank account, or when I withdraw from the bank account, the process of depositing or withdrawing the money is called work. You're getting it? Money is like energy. Depositing and withdrawals are the work. Are you getting the difference? Now, but if I ask you in plain English, pure English, if I ask you what is energy, energy is a noun. It's a quantity. Work is a verb. You're getting it? Fundamentally, what is the difference between them? They're not the same. Is this making sense, everyone? All clear with these definitions? That again, just a rough idea, like when you think about energy and work, this is how you can think of. You can see, right? Energy can also be defined like this. You can say energy can neither be created nor destroyed. Everything, everything is made of energy. Energy simply changes from one form to another form. Now, it's an interesting definition. If you remove the word energy and put God, it still works. God is everywhere. God simply changes from one form to another form. God can neither be created nor destroyed. Right? Everything is made of God. So when you think about that way, right, it actually feels like what science people call as energy, religious people call it as God. Maybe we are not actually, these are not two different things. We are trying to study God using science, and religious people are trying to find God in some other way. Yeah, so fundamentally, if you think about it, it is something of that sort. That's so just have a rough idea. This is how we define this thing as energy and work. Clear with this? So we are looking from the perspective of a caveman 10,000 years back when he didn't have a terminology, but he still understands a stone on a mountain is more dangerous than a stone on a ground. And if you ask him why is it more dangerous, he will say, if it rolls down, if it comes and hits me, I will get an injury, so I'm scared. And if you ask him, okay, so does it have something more? He will say, it has something more, but I don't know what it is because I don't have words to explain it. Making sense? So fundamentally, when you think about anything in the science, it all drops down to that thing only. At some point, you must have felt something. And then you started using words to describe that phenomena. All clear with this? Now let's go to more technical definitions. So what is work? We'll start from there. The symbol is W. It's a scalar quantity. So we'll not at all big definition. Simply work is integral F bar dot ds bar. Straightforward. So here F is the force applied, and what is this ds? This is important. ds is the displacement of point of application of force. We will talk about that in detail. ds is not displacement. It is displacement of point of application of force. Now in this integral, if F is constant, remember this is a dot product. Then the integral comes out of this. This will become F bar dot S bar, which can be written as mod F mod S cos theta. This is what you learned in school, isn't it? Work done by a force is Fs cos theta. S is the displacement and theta is the angle between force and the displacement. So what you learned in school is valid only when force is constant. If force is changing, you have to integrate. Similarly, in one dimension, we can take work done is integral f dx. This is nothing but area under force and displacement graph. So graphs are always there. So if you actually try to plot a graph between f and x, this is interesting, huh? Till now, all the graphs that we have drawn, time can never be negative, but position can be negative. So look at this thing. Anything in this positive x-axis is the positive work. This is also positive work. Because in this region, f is negative and x is also negative in the third quadrant. So a negative negative becomes plus. In the second quadrant, force is positive, but the displacement is negative. In the fourth quadrant, force is negative and displacement is positive. So if I get a curve like this, you have to add all these areas. We have never seen a graph like this, which can be in all the four quadrants. Making sense? That is because generally we used to draw a ft graph. Time can't be negative, so the graph used to be only on the right-hand side. But displacement can be negative. This is your fx graph. Have a look at this. Any doubts on this? Play with the definition? No, let me show an example. That's it. That's just one thing. You're going to play only with this one today. Work done is integral f bar dot ds bar. That's it. With that one, we'll be playing today. So there's nothing more other than the definition of work done. If you want a statement, this is how it will be written. Work done is nothing but integral of dot product of force and displacement of point of application of force there. I just have to tell it verbally and you will write that statement. So it's a boring thing. That definite mathematical definition is sufficient. Let me take an example. Let's say we take a block. Let the block length be 1 meter. And let's say there's a wall here. The wall distance is also 1 meter. And let's say you're applying a force F is equal to 10 newtons. Let this point be A and let this point be B. So when you're pushing the block hits the wall and gets compressed. So it's not a rigid block. The block hits the wall and gets compressed to half meter. So that means this is point B and this is point A and the force is still being applied. Now, if I ask you this question, find the work done, what will you say? If you remember this, you have done on the foundation. But anyways, let's see this thing. During the foundation, we didn't have integration calculus and all that stuff. So this is the problem here. In school, now you never had a problem like this. The block never got compressed. If the block was never compressed, B will travel 1 meter, A will travel 1 meter. There was no problem. Can you tell me what is the displacement of point A and displacement of point B? Look at this. B used to be initially here. A used to be somewhere here. So how much did A travel? A traveled 1 meter and the block got compressed by half meter. So if you actually look at the displacement of A, it is 1.5 meters, whereas displacement of B is 1 meter. Now you tell me, if you use your school ka definition, work done is force into displacement. Which displacement will you take? Will you take A ka displacement or will you take B ka displacement? You're getting the problem? But now if you go with the definition, work done is force into the displacement of point of application of force. I don't care how much is the block moving. I'm only interested in, the point where I'm applying the force, how much it is moving. So therefore, the work definition will be force into displacement of point A, which is 10 into 1.5, that's 15 joules. Is this clear, everyone? Is this understood? there. So be careful. When someone asks you what is work done, don't say force into displacement. It's a blunder. You should say integral f bar dot ds bar, where ds is the displacement of point of application of force. It's not displacement. Clear with this? Let me take one more example. Let's say I have chapati ka dough. You must have seen this chapati ka atta. And let's say you're just holding this with force F. Getting it? So chapati ka dough is held at rest. Now, if you leave it like this, chapati ka dough won't be like this. It will start stretching. So if you ask this question, what is the work done by the force? Look at this point here. Is point A moving? You're just catching the chapati ka dough. The dough stretched on its own. So here, if you look at this, the displacement of A is 0. It never moves. Therefore, work done by force F is 0. So just holding a chapati ka dough, you technically don't do any work. Then who is pulling the chapati ka dough then? Gravity, na? Gravity is pulling the chapati dough.
Yes, sir.
So work done by mg is not 0. Is that clear, everyone? Yeah. Are you getting this thing? So that's what I'm saying. Don't look at the displacement of the body. We don't care. We're only interested in the displacement of the point where you applied the force. Clear with this? Let's say a question based on this. Let's say we have a staircase. And you started walking on the staircase. Oh. Why is he looking like a cockroach? Okay. Anyways. So a boy climbs on a staircase. Find work done by staircase on the boy. I just want positive or negative or 0. Don't want the value. So how much work is the staircase doing on the boy? Work done by boy on the staircase. So when you're walking on the staircase, how much work is the staircase doing on you and how much work are you doing on the staircase? Positive, negative, or 0. That's it. We just want the sign. So is it positive work done or negative work done or 0? Think for a minute. I'll show you this and I'll ask you one more like this. So when you're walking on the staircase, are you doing any work on the staircase? If you're doing, how much is it? Let's see. Yeah, some of you got it. Nah. Yeah, some of you got it. Rest of you got one part right, one part wrong. Okay, let's see. First, let's see the first part. Work done by staircase on boy. Work done by staircase. I can do the other way around. Let's do the work done by boy on staircase. That is easy. Then we'll go for the first one. Listen. So work done by boy on staircase. So who is your system? Staircase. So who is pushing the staircase? The boy. So when you're walking on the staircase, what are you doing? You're pushing the staircase down, isn't it? You're pushing the staircase down with a force F, right? So we push it with a normal reaction. This is the force by boy. Now tell me one thing, what is work done? Force into displacement of point of application of force. So you're applying force on the staircase, but is the staircase moving?
No, sir.
Staircase is not moving. So points on the staircase are at rest. Therefore, work done is 0. Therefore, work done by boy on staircase is 0. So when you're walking on a staircase, you're not doing any work on the staircase. Let's see the first case. The work done by staircase on the boy. This you have to be careful. So your system is the boy now. Now you will see something interesting. See, whenever you're walking, observe how you're walking. One leg is on the ground, one leg is in the air. So if I choose these 2 points A here and B here, where is the force acting? The force is acting on point A, on one leg. Observe this, whenever you're walking, this is what actually happens. One leg is on the ground, one leg is in the air. So here, A is at rest and B is moving. So N is the force by staircase on boy. And if you can see here, A doesn't move. So when, as long as your leg is in contact with the floor, the displacement of A is 0. Right? Therefore, work done on A is 0. So the leg which is in contact with the ground doesn't move. There is a force, but there is no displacement. Look at B. B is interesting. B is moving, but there is no force. The staircase is not applying any force on B. But it is not in contact with the staircase. I don't care about your body cut displacement or your leg cut displacement. We are only interested in the point of contact. But force on B is 0. Therefore, work done by B is also 0. Both the answers are 0, everyone. So when you're walking on a staircase, you don't give any energy to the system. You don't get any energy from the staircase. Is that making sense? Think about it. If you just go and stand on the staircase, will you ever go up? Right? That means staircase is not giving you any energy. If you go and stand on the staircase, will the staircase go down or up? Staircase will never move. So you're not giving any energy to the staircase. So then exactly what is happening internally? Now, this is more of a biology than physics. So what happens is when you're walking, you're using your leg cum muscles like springs. So whenever you're putting your foot down and pressing it down, your leg cum muscles compress. And when you're rising up, the compression pushes your leg up. So you're actually using the floor like a catalyst. You're using the floor to push the energy, and the energy, the force pushes you back. So your muscles get compressed, and with that compression, you keep moving upward. So basically, it is your own energy. You're converting your own muscular or chemical energy into the potential energy. Clear with this? So when you're walking on a staircase, no one does any work on anything. But the story is different if you're standing on an escalator. If you're standing on an escalator, doesn't the escalator give you work? If you stand on the escalator, won't you go up on your own? Clear with this? Any doubts on this part? Be clear with this, then I'll ask you one more. All clear with this? Why both are 0? Now let's see one more question similar to this. Same thing, let's say you went to a mall. You have an escalator. So escalator moves. And the escalator is going up. Right? And now you being there, what you do, you must have done this in a mall sometime. You're bored, the movie is still 1 hour ka waiting is there. So what you do, you started running down the escalator with V. Ever did this? You do this, security guy will come running. So that's a different story, but you must have done this at least once. Right? So this guy started running down with speed V. Right? Just give me a minute. Huh? Someone is knocking the door. So you started running down the escalator, which you should not be doing. Pretty dangerous. So let's say case one, you're running with a speed V less than u. Matlab, escalator is going faster than you. So what will happen? You'll start going up. Case two, V is equal to u. What will happen? You'll be at the same place and just running there. Na? Escalator is going up, you're running there. It's like running on a treadmill. You're at the same place no matter how much you run. Case three, V is greater than you. You're running faster than the escalator. In this case, you will come down completely. So we have three cases. Find work done by, again, three questions. Work done by man on escalator. How much work are you doing on the escalator? Work done by escalator on man. Work done by gravity on man. Again, I don't want the values. You just need to tell me whether it is positive, negative, or zero. So three questions, three cases, total 9 answers. So these are 9 questions, everyone. So case one, you have to give me the answer for all these three. Case two, give me the answer for all these three. Case three, give me the answer for all these three. Total 9 cases, 9 answers here. There are 9 questions. Let's start with the first one. V less than u. Let's find all of them. It looks big, but answers will come out pretty fast. You try for 2-3 minutes, then I'll show you. Anyone didn't get the picture, please ask me. Escalator is going up, you're running down the escalator. There are 3 ways you can run down. You are slower than the escalator, you're equal to the escalator, you're faster than the escalator. In all the 3 cases, what is the work done by man on escalator? How much work are you doing on the escalator? How much work is the escalator doing on you? How much work is the gravity doing on you? You don't want the values, we just want whether it is positive, negative, or zero. Think, you got 2-3 minutes. Everyone should try. It's completely fine to get wrong answers, but you need to think. Anyone didn't understand the question? Any confusion? Please ask. Question is clear. Go ahead. Aditi, give me all three. Na? Case one, give me 3 answers. Case two, give me 3 answers. Case three, give me 3 answers. That would be better. And think carefully. Yeah? When you are walking on the escalator, always think how you are walking. Work done does not depend on the displacement of the man. Work done depends on the displacement of the point of application of force. So your head can be moving front, but if your leg is not moving, your work done is zero. That is the most common mistake. People think something is moving, to work done hona chahiye. Like I said, we don't care about the displacement of the person or the block or anything. It is displacement of the point of contact. Samyak got something. Positive, negative. Let's see. I'll show you. You don't take man as a system, Trishi. Because what is the work done definition? Displacement of point of application of force. Now you tell me, escalator ka force will act where? On the man or on the legs? Legs, na? So you don't care about the man. You only look at the leg ka point of contact. Your feet and the escalator. That's it. That is the game. I don't care what is the man actually doing. Let him jump from there. They're only interested in the point of contact. negative, positive. Let's see. I don't remember the answers even. I need to check. But try for a minute or two, then I'll show you everything. Siddesh got something. Positive, negative, negative. Okay. Okay, let's see. Actually, the first one answer is independent of all the three cases. Like I keep saying, always look at the man ka leg. Let's see the first case, everyone. The work done by man on escalator. When you are coming down the escalator, what are you exactly doing? So if you look at your legs, one leg is like this, one leg is like this, isn't it? You're coming down, no? Forget about what the escalator is trying to do. What are you trying to do? You're trying to put one leg down and one leg on the escalator. Isn't this how it looks? So just look at this point here. If you look at this point here, A, and if you just look at this point B here, so one leg is on the escalator, which is at rest. Can you tell me how is this point moving exactly? A is going up, na? So the leg in contact with the escalator goes with the escalator. So when man walks on the escalator, one leg is in contact with the escalator, the other leg is in air. It doesn't matter whether you're going up or down. This is the story there. When man walks on escalator, one leg is in air. That is your point B. The other leg is touching the escalator. That's your point. And you can clearly see A goes up with the escalator. Now that is a whole catch. You have to remove that leg A faster than the B falls there, or else you won't get down. A goes up with the escalator. So it doesn't matter how fast you're running. You're walking, you're running, the point A will always keep going up. And what about the force? The escalator is pushing you up with force. This is the force due to escalator. And what is the angle between them? Theta is acute. Therefore, work done, Fs cos theta. The work done by escalator. This is actually the B part. On man is always positive in all three cases. Making sense? And B में तो work done है ही नहीं, because B में there is a displacement, but there is no force. Similarly, if you look at the story from the other waypoint, same thing is happening. You're only interested in point A. So this is point A, which is going this way. And what is the man doing? The man is pushing the escalator down with a force F. That will be the N. This is force due to man on escalator. And if you look at this theta is obtuse. So work done by man on escalator is negative in all three cases. It doesn't matter you're going faster or slower, this is always negative. Is this making sense? Now try to understand this logically. Yeah? Think about it. If you're trying to get down the escalator, how is the escalator going up, right? Escalator is going up. Whether you're trying to get down, whether you're trying to go up, or whether you're trying to stand, escalator will always try to take you up. Means escalator is always trying to give you potential energy, isn't it? So that is the reason you'll always get positive. It doesn't matter what you are trying to do. What is the escalator trying to do to you? Escalator is always trying to take you up. So it is always giving you energy. Making sense? And look at your case. What are you trying to do? Whether you're going up or coming down or you're standing there, you're always pushing the escalator down. You're stealing energy from escalator, isn't it? That's the reason we need to give electricity to escalator to keep it running, or else it will stop. That's the reason it is always negative. All three cases. Any doubts on these two cases? Please ask. All clear with this, Pratyasha? Siddesh? Aditi? Samyak? Devanshi? Clear? Yashvi? Vedika? Third case, the gravity. This guy will change. So in case of a gravity, we have three cases. Escalator is going up with you, right? And you're running down with V. So the gravity ka force acting on you is mg down. So if your speed u is greater than v, man goes up. You're trying to get down, but the escalator is dominating. That means man ka displacement is up and mg is down. The angle is obtuse. Work done is negative. Gravity is pulling down, but you're going up. If u is equal to v, you will just remain at the same place in the ground frame. The work done by gravity is 0. If u is greater than v, if u is less than v, that is man is going down, gravitatically it will matter how fast you are walking. In this case, your displacement is s down and your mg is down. The angle is acute. The work done by gravity is positive. Clear with this, everyone? All clear with this? Let's see one more. Any doubts on this? When v is equal to 0, there's no displacement. Then how is displacement not 0? I didn't understand the Rishi. Displacement of whom you're talking? Which one you're talking about? Work done by gravity or work done by escalator? You can just unmute and ask.
In all three cases.
No, abhi dekho na. When you say work done by man on escalator, escalator on man, what are you looking at? You're looking at the point of contact, isn't it? But when you say work done by gravity, where is the gravitational force acting on you? It is acting on your entire body, isn't it? Where is gravity acting? It is acting on the entire body. तो पूरा body का displacement लेना पड़ेगा ना? You getting the catch? But when I ask you work done by escalator, you will take only the displacement of the points which are in contact. Is that making sense, the sentence?
But when V and U are equal, there is no displacement.
No, there is no displacement of the man, but the legs का displacement नहीं है. Again, ask yourself how you are walking. Huh? Actually, क्या हो रहा है ना? I'll tell you. See, when you are walking, when U is equal to V, this is what is happening. One leg is on the escalator, one leg is here. So this leg is going up. By then, what you do, you jump onto this thing, and then this leg comes into the air, isn't it? Then this leg again comes to the ground. Then this leg comes front. So the point in contact is moving, right? You're getting the catch? Agreed. Man ka displacement nahi hai, but your legs are moving. So tell me one thing. So when you're running on a treadmill, doesn't it mean you're at rest on a treadmill? But doesn't it mean your legs are moving? देखा? On a treadmill when you're running, you're not moving, but your legs are moving. So यहाँ पे reverse था. Legs are moving, but the man is not moving. Because the escalator is going away. So it is something similar. I hope all are clear with this. Theoretical questions. So you can play around like this with the escalator and everything. Let's see one more. Let's see some numericals kind of thing. Let's do an easy one. Then we will go for one more theoretical question. Too much theory, you guys will get bored. Not bored, actually, you get fried. But anyways, Mewis 0.2, 10 kg. We are applying a force F is equal to 20 root 2 newtons. We have seen something like this in friction. This is 45 degrees. Initially at rest, find work done by capital F and friction in 2 seconds. Initially, the block is at rest. There, let's get this. There, everything is back. NLM, kinematics, friction, work per energy. 4 chapters. And you have done this question. If you have not realized it, same question. Find distance shuttle block in 2 seconds. The mass is different though. This is what I keep saying. Physics mein things will keep coming, keep popping up. Whatever you learn will keep popping up. That's what makes the subject easy actually. If you have revised, you remember your stuff, it will help you. But even if you forget, that is also an advantage. Because you forgot, now you have a chance to revise the old topics. So either way, it is a benefit. That's the reason, if you see the top 5,000 rankers, if you ask them what is their favorite subject, at least 4,000 people will say physics. Again, I'm telling you, when the portion gets over last May, like 1 month before the advanced exam, let's say if you're studying every day 10 hours, people do study 10 hours, right? You have nothing else. So you know how they study normally? Max 4 hours, chemistry 4 hours, physics 2 hours. Kafi hai. Physics is special in that case. It saves your time. I can give you 50 problems and cover entire portion. You can't do that with max and chem. Anyway, let's get this thing. Work done by friction and work done by force F in 2 seconds. I want values, right, Ishman? I don't want positive, negative. Numbers. I want numbers. There are 2 questions, right, Aditi? Work done by capital F and work done by friction. There are 2 forces acting on the block. Get me the work done for both of them. That looks right, Samyak. We have one answer, everyone. Anyone else? And others, do keep your cams on. Aditi. How can you get 0? Siddesh, give me the work done by capital F also, Nare. Give me both. There are 2 questions there, everyone. Capital F and friction. Nee, Shaurya, that is wrong. Take G as 10, huh? Right, Siddesh. We have 2 answers. One more. 30 seconds more. Step 1, draw your FBD. That's how you always start. Find the acceleration, find the displacement, and then do F into S. You're done. Nesh, man, you messed up something. Let's see. Step 1, free body diagram. This will be F cos theta, 20, F sin theta, 20, your own weight, 100, normal reaction, friction, F max, because 20 is greater than F max. Normal reaction is 80 newtons. Hope you didn't do that mistake. N is not 100. n हर बार mg नहीं होगा. And then F max will be mu n, which is 0.2 into 80, which is 16 newtons. There, 20 is greater than 16, so the block will definitely slide. Therefore, it is F maximum. And acceleration be A forward. So this will be F cos 45 minus F max is equal to ma. We have done this before, so I'm skipping the steps. This is 20 minus 16 is equal to 10 into acceleration. So A is equal to 0.4 meters per second square. You said work done in 2 seconds. So acceleration is constant. I can use S is equal to ut plus half at square. Therefore, displacement is equal to half into 0.4 into 2 square. That will be 0.8 meters. Luckily, it's a rigid block. There is no compression and all. So all points will move the same displacement. So work done by capital F will be F into S into cos theta because F is constant. Or you can simply say the horizontal force will do work, vertical component will not do work. So I can write like that also. F cos theta into S because the force got two components. So that will be 20 into 0.8. Both are in the same direction, so 16 joules. Work done by friction. Friction is acting backward, so minus F max. Displacement is forward, plus S. That's minus 16 into 0.8. How much is that? Minus 12.8 joules. You get a minus sign because friction is taking away energy from you. Is this clear, everyone? The angle between friction and displacement is 0 degrees or 180 degrees. That's why you get a minus sign. Any doubts on this step? Please ask me. All clear with this? So if you see till here, everything was same, right? Kinematics, friction, FBD, and everything. Only thing you just multiplied F into S. Let's see one more. We have a pulley here. We have a block of mass 2m. We have a block of mass m, atwood mission. We have two people. One person is standing on the ground. Another observer is standing on M. There are two people standing there. So the question is, gravity is there. Find work done by the tension on the string find work done by tension on the blocks in 2 seconds. As seen by, again, there are two options. Case 1, observer A. If you ask observer A, boss, what is the work done by tension? What will he say? If you ask observer B, what will he say? Remember, A and B are observers, massless. So neglect the mass of observer. Observer is just a hypothetical thing. Are you getting the question? Do you agree there will be tension force on the blocks? Do you agree blocks will move? So if there's a force and there's a displacement, there'll be work done. So tension is doing some work. But the question is, two people are looking at the blocks. So the question is, what is work done with the tension on block M, block 2M, as seen by A? Find the work done by tension on block M, block 2M, as seen by B. There are 4 questions, everyone here. 2 blocks, 2 observers. So there are total 4 questions. Let's start with A. If you ask person A to calculate the work, what will he say? But before that, find the tension and acceleration and displacement. That's all NLM. Hope the question was clear. Someone is not clear with the question, please ask. I'll explain again. Question should be clear. So this is one important thing. Work done depends on who is looking at the problem. If the observer starts running, the work done gets messed up. Shaurya.
Sir, like mass of B is given in the question or not?
अरे it's just an observer ray, it is
अच्छा,
hypothetical.
observer. Okay.
B का कुछ मास नहीं है. If you want, I'll write it down. Massless observer. Let's find tension in the string. Start from there. Find the tension in the string, find the acceleration of the blocks, and find the displacement in 2 seconds. इतना तो कर सकते हो. Let's start from there. That's all loss of motion. There's no work per energy in that. Get that? I'll give you 2 minutes. Then we can see. Let's see. 80 mg by 9. This thing. Samyak, that looks right. Right, Aditi. First part is right. So let's find the tension first of all. This is a simple Atwood machine, everyone. Hope you remember the standard results. This is tension. This is tension. This is going up and this is coming down. So tension ka formula is 2 m1 m2 by m1 plus m2g. Yeah, you can always write the FBD and solve, but if you remember, it will be great. 4 mg by 3. Acceleration m2 minus m1 by m2 plus m1g, which is g by 3. We are doing all this in the ground frame. So displacement is equal to s is equal to ut plus half at square. So this will be half g by 3 into 2 square. So displacement is 2g by 3. Clear with this? Now, if you ask A to solve the problem, this is what A will say. A will say 2m has come down, m has gone up. Initially, there used to be somewhere here. So this displacement is up, tension is also up. Here the displacement is down, but the tension is up. So he will say work done on m will be plus t into s, both are upward. Work done on 2m will be t, displacement is minus s, up, positive, down, negative, minus ts. That you can multiply the values and you get the answer. How much will that be? 8 mg square by 9. This will be minus 8 mg square by 9. And obviously they should be equal and opposite. You know why? Remember power method in constraints? The total work done by tension is always 0. So tension is simply taking energy from one system and giving it to another system. So total to 0 hona chahiye tha. This is A ka frame. Any doubts on this part? Now let's ask B to solve the problem, but have a look at this. If you are not convinced with this, please ask me. Right, Anvita, you got it. Shman, you got it. I think, but minus sign missing, I guess, right, Ashman? Any doubts on this part? Please ask me. Sudiksha, clear with this? Utsa? Utsa, clear with this? I can't see you, right, Utsa? Do adjust your camera a bit. Shreyansh? Clear? Shreyansh, clear with this? Advai? So let's ask B to solve the problem. Now B will say something interesting. B will say, I'm standing on block M. This is to M. So observer B will say, M is not moving only. Because if you're standing on the block, it is always under your feet. So it is always at rest. So work done on M is zero. He will say it is zero displacement. And if you ask him what is this displacement, he will think this is gone down by 2s and tension is up. So according to him, work done on 2m will be tension and displacement is minus 2s. He gets double the negative work. This is what B will say. The reason they don't become zero is because you're standing in a non-inertial frame. So you have to apply pseudo force. So the whole game changes. We will talk about that later on. So this is an important statement, everyone. Work done depends on frame of reference. If the observer starts moving, you will get a different work. See, two people are giving two different answers completely. Is this clear, everyone? Any doubts on this? Any confusion? Anyone not clear with anything here? Please ask. Clear? Take a small break. Come back by 9:35. We'll continue from here. Any doubts so far? Chalo, come back in 5 minutes then. Yeah, let's start off. Wait, let's see one more. So a pencil is used to draw a circle of radius r. Others comes on a paper. The friction between the pencil and the paper is F. So you're getting how it is. So we have a paper. You have taken a pencil, and let's say you just made a circle. So with a pencil, you have just drawn a circle. The circle का radius is r. So find work done by pencil on paper. Find work done by paper on pencil. Let's get this in one revolution. So if you make one complete revolution in one circle, so let's see how we do this thing. Because in school you learn something. If the displacement is zero, work done is zero. Did you study something like that? That's a blunder. It's not wrong, but they forgot to tell you something. Let's see whether you will. I want values, right, Aditi? Don't want positive, negative. I want values. Diya na F and R are diya. Answer has should be in terms of F and R. Let's try this, everyone. It's a good one. It's a good theoretical one. So you took a pencil and you drew a circle of radius R. Friction between the pencil ka tip and the paper is F. What is the work done by pencil on the paper and work done by paper on pencil? Let's see how you approach this.
So in one revolution, right?
Yeah, circle मतलब कितना revolutions होगा?
हाँ मतलब yeah.
If you want, you'll write that also in one revolution. This is a good one, right? Give it a try. I'll show you something. We have a lot of good theoretical points in this. Samyak, we need to get the signs also. Right, Shaurya. Right, Devanshi. Get me the second one also. Right, Aditi. Let's see. That is right, Ujjansh. First part is right. Let's see. Work done by pencil on paper. So who is your system? So you're pushing the paper, getting it? So when you are drawing the circle, tell me one thing, are the points on the circle moving? Are the points on the paper moving? They're not moving. So therefore, if you see, there is a friction everywhere. But none of the points are moving. So if you take any point here, A point is not moving. So points on the paper are at rest. So friction on the pencil will be in the opposite direction of motion, whereas the friction on the paper will be in the direction of the motion. So friction on the paper will be in the direction of motion. Think about it. If you take your finger, put it on the table and drag the table, on your finger, friction will be backward. On the table, friction will be forward, isn't it? So friction on the paper is in the direction of the motion. Right, and you can clearly see here, points on the paper do not move. Therefore, work done by pencil on paper is zero. Pencil does not do any work on the paper. Clear with this? Let's see the second one. Work done by paper on pencil. Now, this is important. So when you're going on a circle here, so when the pencil is moving, the friction on the pencil cut tip is backward, and the displacement of the tip of the pencil is forward, ds. You're getting this? Now here you have to be careful. So what you learned in school now, if the displacement is zero, work done is zero, it's a blunder. There is a thing for that. It's not always true. So here, if you look at friction in ds are always anti-parallel. Friction is not constant here, everyone. F ka magnitude is constant, but direction is changing. Here, magnitude of F bar is constant. Therefore, F bar is changing. Okay. So what is work done ka formula? Work done is integral F bar dot ds bar. So here, friction mod F mod ds. The angle between them is cos 180. Now see, mod F is constant. F is not constant, but mod F is constant. So you'll get minus F integral mod ds bar. Now, this is something I taught you in kinematics. So what is ds bar? Tell me one thing. So when you take a vector here, this is your ds bar vector. Can someone tell me what is the difference between these two? What is integral ds bar and what is integral mod ds bar in one revolution? What is the difference between these two? What is ds bar? Ds bar is a vector. So when you add all the vectors, what do you get? If you add all these vectors, you come back to the same place. So you get displacement. In one revolution, displacement is 0. If you add mod ds bar, what are you adding? You're adding scalars, no? You're adding length of each piece. So what do you get? You get distance. This is nothing but circumference 2 pi r. Is this making sense, everyone? Putting a mod inside and not putting a mod will change the whole thing. You're integrating a vector here and you're integrating a scalar here. Any doubts on this part, everyone? So now when you integrate this, you will get minus f into 2 pi r. This is your work done by paper on pencil. So again, if you notice something, Newton's third law does not apply here. What is Newton's third law? If I apply force F, you'll apply force F. So here, look at this. Work done by pencil on paper is 0, but work done by paper on pencil is not 0. So there is no concept like third law here. So if I do work on you, there is no guarantee you will do work on me. So we don't have any concept. Concept of Newton's third law. That is work done by A on B need not be equal to work done by B on, sometimes it can be. This is not guaranteed. Is this making sense? Then what did you learn in school? If displacement is 0, work done is 0, what is that exactly? But all clear with this. So let's talk about that, what you learned in school then. Pretty good question, right? Not a tough one, but yeah, you have to have a little theoretical idea there. And again, see, whole class today, what did I do? Did I teach you anything new other than integral FDS? Whole class, we are just playing with that one equation, integral f bar dot ds. So what did you learn in school? This is what you learned in school. If f bar is constant, then your work done, which is integral f bar dot ds bar, this comes out of the integral f bar, we get integral ds bar. Then this becomes f bar dot displacement. So here you get. So if displacement is 0, then work done is 0. So this statement, right, is valid only when f is constant. F bar is constant. So what do you mean by that? Meaning the situation should have been like this. If a particle is going in a circle, f is constant, matlab kya? The force ka direction must be always in the same direction. You're getting it? So here the displacement is this way, but the force ka direction is always in the same direction. This is the meaning of constant force, constant magnitude and constant direction. Is this making sense? In the previous case, is friction constant? Friction is not constant, isn't it? F bar is not constant, mod f is constant. Here F bar is constant. That means even if you have some random amoeba path, as long as your force is constant, work done is 0. It doesn't matter how you travel. If your F is constant, then the work done is always constant. Then this work is 0. So clear with this? So in school, what you studied was this. So this is the statement there. If the force acting on a body is constant, both in magnitude and direction, then if the displacement is 0, work done is 0. Clear with this? So examine the last questions like this. If displacement is 0, work done is 0. True or false? False. Right? It's a special case. If force is constant, displacement is 0, then work done is 0. Any doubts on this? Please ask me. All clear with this? Let's see one more. Any doubts on this thing? People are exhausted for some reason. I don't know why. Don't be exhausted. When you feel tired and sleepy, what to do? Do 5 push-ups. It helps. Even girls should do 5 push-ups. Pull-ups are difficult, but it works. When we were in 11th and 12th, we used to do that. Every time I get a question wrong, do 5 push-ups. Either you'll get the question right or else you'll build your body. That's the concept. We didn't have any internet at that time, so we used to do all crazy things. I always had a problem remembering inorganic things. So you know what I and my friend we used to do? We used to play a game every day. Every day he will ask me 3 questions from organic and inorganic from anywhere he can ask. Getting it? He will ask me 3 questions. For every question that I can't answer, he will punch me once. Similarly, I will ask him 3 questions. If he can't answer, I can punch him once per question. So every day 6 questions. Now imagine the game, and you can punch really hard on the shoulder. At least shoulder the strong hoga na. We are crazy people. So in order for him not to get the answer, I used to search for all weird, tough questions and ask him. You also used to do the same thing. And a game mein ek rule tha. You can ask the question anytime, anywhere, right? And after the question is asked, you have to tell the answer within a minute. This was the rule. And this idiot used to sit behind me. And during a maths class or physics class or chemistry class, sometimes teacher used to make me stand up for asking something. Maths teacher, one time it happened. Maths teacher asked Arun, what is this question? I stood up and this guy from the back. What happens if you combine alcohol with this reaction? And rule tha and the hopeless thing is I know the answer for that thing. I just need to answer that, but Age maths teacher is looking at me to answer me something on the board. I couldn't answer. And this guy punched me right and left. Right. So then I was very pissed off. Next day when he was in the bathroom, I locked the door, I threw a bucket of water, then I asked a question. The game went on. We played almost for 2 months, I guess. And then we started getting punched more and more. And then we realized, boss, our organic, inorganic बहुत strong ho gaya. There's no need to play the game anymore. But think about it now. When we played the game for a month, almost 25 days, every day we are getting 6 questions, 25 into 6. That's almost 150 questions we solved per week, per month. And what kind of questions? The questions which he can't answer, questions which I can't answer. We are asking such kind of questions. It was a big revision, right? One of the reasons my inorganic was so strong, even though I can't remember names properly. Every punch you remember, right? You don't remember the names, you remember the punches. It worked. So same thing for you also. When you have a problem remembering, best thing to do is do a Viva. So all the questions are there, give it to someone and tell them to ask you questions. So when you do that, right, you have a better recall, you remember stuff better. You might forget, then look at the answer. Next time again, when they ask Viva, then remember. Because no matter how many times you read, it doesn't really help much. But when someone asks you a Viva, you remember very well. That is how I conquered inorganic. So there. Shaurya, is there a question related to physics? Or if it is random, non-academic stuff, don't ask.
Sir, like revision-based question on what you said.
No, that I don't care. That I'm just telling you random stuff. Your revision, there is a lot of time. Next year, dekhte. Let's focus on class. रिवीजन क्या रिवीजन पूछोगे अभी? अरे स्टार्ट होके 3 months भी नहीं हुआ रे शौर्य. 4 months maybe. Let's see one more. Yeah, something. Wait, end of the class, no? Ask me non-academic stuff end of the class, not in the middle. Anyway, I'm just telling you something. So you'll have a lot of stories like that. People will think you're crazy, but as long as it is working for you, it works. So again, we got some random weird path here. Height is h, length is l. the friction is mu. It is rough. This is seeing a random path like this. So on this surface, you kept a block of mass m. So this block m is slowly sliding on this rough path. Slowly, meaning negligible velocity. You think losing contact. Find the work done by the friction and the gravity when it comes down. What happens if you have a constant velocity? Not zero speed, but you have some constant velocity. Then what is the problem? Can't you solve the problem with the constant velocity? First, let's do the first part. Then we'll think about the second one. If you have zero speed and you're slowly dragging this block on this rough surface, friction will do some work. Find the work done by friction and the gravity when it comes down. Minus mu mgl mgh. Okay, Srihari, you got it. I hope you know the process. Did you do this before already? That is okay if you have done before, but do it again, no? You should remember at least how to do. Because if you say something like that, what I will do now, exam I will say mu is equal to mu naught x, and you will die then. It is pretty simple to mess up the question. Physics, that's the biggest advantage you can have. If you don't know the process, you will get stuck. Remember the answers, that is fine, but always remember the process also. If you remember the answers, you will do better in exams like CET and main. But if you don't know the process, advance and bits and all these things, will get slaughtered. Try. I'll give you a minute or two. It's a good one. Let's see. Right, Suresh. We have done things like this before. I told you how to take the elements. A rope was hanging on a curved surface and all that stuff. So let's see. So consider a small slice somewhere. ds. So if you take this small piece here, I can treat it like this an incline theta. This will be dy. This will be dx. So we have our block here, M. So on this, the forces will be mg sine theta. Right, and this will be your mg cos theta. This will be your friction. Because it is sliding, it is maximum, and this is your normal reaction. So this is ds, this is dy, this is your dx, and this is your theta. So here normal reaction is mg cos theta. Since it is sliding, friction F max is equal to mu n, which will be mu mg cos theta. Great. So work done by friction will be minus integral F into ds, because friction is backward and the displacement is forward. So if you look at that block there on the curve, the displacement is forward ds and the friction is backward. That's why you're getting a minus sign. So minus mu mg cos theta into ds. But what is cos theta from there? So ds cos theta is nothing but dx. Because cos theta is dx by ds. And x limits will go from 0 to L. We get minus mu mgl. The work done by friction here is independent of the path. It doesn't matter what kind of shape you take, it's always mu mgl. Clear with this? What is work done by gravity then? The work done by gravity, luckily, the gravity is a constant force. Minus mg j cap, force, dot product, displacement. What is the displacement? L I cap. You're going horizontal direction L and the vertically minus h j cap. This is your displacement vector. Remember what is displacement? Line joining initial to final. This is your displacement. What is this thing? L. What is this thing? H down. So L I cap and minus h j cap. Is that clear? And what is the weight? Weight is always mg downward. So what is the dot product? I cap, j cap, and this thing will be mgh. There. This is the work done by gravity. Again, work done by gravity doesn't depend on the path. It depends only on the height. This clear, everyone? So on this weird random surface, if you move the block slowly, no matter what is the shape of the surface, the work done by friction will depend only on the horizontal distance. Any doubts on this? Then the second part of the question. What if the block has a speed? Instead of negligible speed, if you have a speed, what is the problem? Think, I'll give you a minute or two. Instead of having zero speed, if you have some constant speed, maybe 1 meter per second, 2 meter per second, something. What is the problem? Can't you solve the problem? Can you think what is the issue there? You can't solve the problem. Okay? Why can't you solve the problem? Tell me what is the issue. Take a minute. If the block has negligible speed, you can solve the problem. But if the block has a constant speed, acceleration bhi nahi hai, constant speed, you can't solve the problem. Why? Think. Right, Samyak, but how does that affect? You're thinking in the right direction, but how does that affect? Anyone else? Any guesses? Any ideas? If you move with a velocity, what is the problem? You have an issue. Siddesh says we cannot find n. Okay, Siddesh, why can't we find n? Again, you're going in the right direction. Right, Samyak? What you said was right. Anyone else? We have one answer from Samyak. What happens is this, listen. So when you're going on this random curve, at some particular point here, if you see, this will be a radius of curvature. Now, if you draw the FBD of the block, what are the forces acting on the system? Normal reaction, mg cos theta, and there will be a centrifugal force, mv square by r. So the normal reaction becomes mg cos theta plus mv square by r. I can actually calculate n ka value, but the problem is r changes at every instant. And since you didn't give me the equation of the path, we cannot find r. Without the equation of the path. So it actually starts depending on the path. If you give me the equation of the path, I can use the radius of curvature formula and I can find n. Therefore, n cannot be calculated. But if v is tending to 0, this is the catch. If v tends to 0, negligible velocity, then you can say n will be tending to mg cos theta. That was the approximation we did. That's the reason I said n velocity is negligible. Clear with this? So if the speed is not negligible, you can't solve this problem. Yeah, right, Siddesh. All clear with this? That is a catch. So this problem can be solved only when the block is moving slowly. If you have some speed, you're gone. Next one. Any doubts on this so far? Please ask me. Clear, na, Tanishka? Yashvi? Clear? Utsa? Utsa, can you adjust your camera a bit? I can't see you actually. Meaning the curtains are good, but we have to see your face so that we know you're not eating some cake or something secretly. Happens a lot. I'm taking a class and someone is sitting and eating a popcorn. You must have done this thing na, during COVID time, no? During COVID time, the people used to do any nonsense. Next thing. So normally in our offline classes also, right? If people are hungry, I tell them, see, it is okay, you can eat something. Even in IIT, our professors never scolded us for eating. So some professors never scolded. We used to bring coffee, biscuits, we used to sit, but again, keep it under the table and eat silently. You don't open it in front of like a restaurant and then you're eating it. So there is one idiot like that who used to do that. I did a course in IIT. It's a filmmaking course. In IIT, you have something called free electives. So IIT Madras, right? That time we used to have 5 free electives. Means you can do any course you want. 5 courses. So one of the course that I did was how to make films. Movie making course. Right? Every week there used to be one class on Thursday evening 7 to 10. The teacher used to put a movie. You have to go to the classroom. There is a projector. You watch the movie for 3 hours. That is a class, huh? And then you come to your room and then you have to write a review for the movie. That's your assignment. For each review, you get 10 marks. Like that, the entire semester teacher showed us 5 movies, so 50 marks. And the final exam, what is the final exam? You have to take a 7 minutes short film. So go get 50 marks for making a short film. 100 marks ka paper. So teacher used to say, teacher used to give us free coffee, free biscuits, but you want to eat something else, you have to get it on your own. So 7 to 10 people used to bring Pepsi, popcorn, kuch bhi leke aate the. So first day, first movie thing, right? We all thought some nice movie will be there. We all went pretty excited. Teacher kept a movie which was 1940s ka, some old English movie. Historical movie, it seems. 1940 that movie was made black and white. We are looking in the movie, and for 1.5 hours, we are literally crying like, "Bas, kya chal raha hai? What is this movie about?" It was an interesting course. So I did a lot of weird courses like that. I did a course on how to make ships. I did a course on how to write books. I did 5 courses like that. So I did all weird ones. I did one course on Chinese economy and contemporary science, blah, 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 something. So you get a lot of freedom to do that. Right now, so even you have more freedom, you have a lot of clubs and everything. So that's the advantage of going to a good college. If you get into these local colleges, right, you still have all this stuff, but there's too much focus on, journal writing, that, this, all nonsense. And did I tell you, right, BITS ka cutoffs have come down this year? I didn't tell you guys. Yesterday, BITS ka cutoffs have come. Till last year, if you want to get into BITS Pilani computer science, you need to score 327 out of 390. This was last year ka BITS Pilani computer science ka cutoff. This year it is 304. So this year, many of your seniors actually went to BITS than IITs. So even for BITS Hyderabad, last year cutoff was 290 something. This year 270. If you get out of 390, you're getting into BITS Hyderabad computer science. So cutoffs have come down considerably. 30 marks is a huge difference. Anyway, that's a good news. But let's see. By your time, don't know what will happen. Next thing. Your seniors are dead scared right now. Because so far in the trend, 2006, the paper, there was a huge change in JEE Advanced. This year I wrote. 2016, the paper was a disaster. Matlab, it was a slaughter. Now to 2026. Today, someone was telling me in the morning. So there is some problem with Sixer, and 2026 is our year. 2016 is said to be one of the toughest paper. 2006 was one of the most, the paper pattern completely changed. Till 2005, the paper used to be subjective. You have to write the answers. The paper completely shifted to the paper you're seeing right now. So every 10 years, there was something. Someone created a pattern like this. Not sure what will happen. Then I was telling them, see, if the paper is tough, it is good for you. Because everyone will mess up the paper, cutoffs will come down, you'll get a better rank. This is something you need to understand. If you're good in a subject, paper must be tough. Because see, if you're good in a subject, paper comes easy. You will score 100 out of 100. But every other idiot will score 80. The difference is only 20 marks. But if the paper comes tough, you'll score 60. The other guy will score 10. The difference is 50. You'll get a better percentile and a better rank. So how to get a good rank? You should study well and others should mess up more. Then you get a good rank. Getting it? Anyways, so a body moves from point A, 1, 1, to point B, which is 2, 3. Under the action of force, which is 2i plus 3j cap. So I'm giving you the force and I'm giving you the initial and the final position. Second question, F2 will be xi cap plus yj cap. Yi cap plus xj cap. Two x y cube I cap plus 3x square y square j cap. Let's see how will you solve this. So find work done by F1, F2, F3, F4. So when you're going from A to B, there are 4 forces acting on the particle. What is the work done by each force when you go from A to B? Let me help you with one question, then I'll give you an idea. Listen to the first one. First one is actually quite easy. You can directly do f bar dot s bar because f is constant. But let me show you a general process. Listen to this. First of all, what is r bar? We did this in vectors. If you have a point P here, this is your r bar. So if the coordinates are x comma, y comma, z, r bar is xi cap, yj cap, and zk cap. So what is dr bar? Dr bar is a change in vector, which is your displacement. Dxi cap, dyj cap, dzk cap. This is your displacement, small displacement. So if someone is asking you to find the work done will be integral f bar dot dr bar. F bar is nothing but force ka three components, fxi cap, fyj cap, and fzk cap. Dot product dxi cap, dyj cap, and dzk cap. So I am just showing you in a more generalized form. So when you do the dot product, the work done becomes integral fx dx plus fy dy plus fz dz. This is how you get the work done. This is your general method. Getting it? Now let's see the first part. What is your force? 2y plus 3j. So what is the work done? Integral 2y plus 3j. Again, I'm writing everything for you. Dot product dxi cap, dyj cap, dzk cap. So you know how to do the dot product. Only the I components will multiply, j will multiply, and so on. This will be 2 into dx plus 3 into dy. There is no z. So x is going from where to where? You're going from 1, 1 to 2, 3. So you are going from A to B. So you're going from XA to 1 to XB, which is 2. You're going from YA, which is 1. You're going to YB, which is 3. That is the limits. X is going from 1 to 2. Y is going from 1 to 3. So this integration will be 2 into X. Limits will go from 1 to 2. This will be 3 into Y. Limits will go from 1 to 3. That will become 2 plus 6. That will become 8 joules. Understood how I did this? Have a look at the process. So that is how you do the work done. F bar dot ds bar. So write f bar in vector form, write ds bar in vector form, do the dot product, and then integrate each term. Is the process clear, everyone? Now, can you try the remaining 3? Let's finish off. Last one for the day. That should give you some energy. Let's go. What if force is xi cap plus yj cap? Matlab force is changing with every x and y coordinate. So what will change here? बस ये 2 का place में x will come, 3 का place में y will come. That is the only change. You can try the second one, xi cap plus yj cap. I will keep this here. You can use this as a reference and solve. Try, I'll give you a minute. Right, Siddesh, but minus आएगा क्या? I don't think you'll get a minus. Or did you mean to say b is equal to 5.5, Siddesh? Okay. मेरे सम्यक C and D are not 0. C and D are the actual questions. Right, Utsa? A and B are CT questions. C and D are actual mains questions. They'll even go to the advanced questions actually, C and D. Try. I'll give you a minute more. B is easy. You should have got it by now. Most of you are getting it actually. Yeah, right, Siddesh. That is a name for it. I think you learned it. Good. Right, Srihari. Right, Aditi. All of you got the B part. So what is B part, everyone? See? Same story. Work done is integral f bar, which is xi cap plus yj cap dot dxi cap plus dyj cap plus dzk cap. So this will be integral x dx plus integral y dy. So x limits are going from xa to xb, y limits are going from ya to yb. This will be x square by 2, 1 to 2 plus y square by 2, 1 to 3, this will be 11 by 2 joules. This was easy. Any doubts on this thing, please ask me. Let me show you C question, then I'll give you time for the D part. C is different. Any doubts on the B part? Now look at C ka question. Y I cap x j cap. Matlab force in the I direction depends on y coordinate. Force on the j direction depends on the x coordinate. It's a pretty weird force. So work done will be integral y I cap plus x j cap dot dx I cap dy j cap and dz k cap. So if you integrate this, you'll get integral y dx plus integral x dy. You cannot integrate this because see, y is also variable, x is also variable. You cannot integrate this directly, but you can do something interesting here. When you mix them together, this can be written as integral y dx plus x dy. Think about it, doesn't this look like, if you differentiate x into y, product rule, how does this look like? Y will come out, differentiate x will come out, differentiate y. Isn't this? So you can write this whole thing as integral d of xy. So you cannot integrate each term separately, but when you keep them together, suddenly you can integrate. So we are treating this xy as a new variable. So you can call it xy is equal to some t or something. So you have a lot of kind of things. For example, if you have dx square y, this can be written as y into 2x dx plus x square into dy. These kind of equations are called perfect differentials. Remember this, quite a useful thing. It will come up again in the next class also. So if you can convert something into a single term, it's called perfect differential. That is a term for these kind of functions. There is a name for this thing. These are called perfect differentials. Clear with this so far, everyone? So you cannot integrate each term separately, but together you can integrate. Now let's try to integrate this. So we get work done is integral d of xy. So what we can do for convenience, so that means what is happening here? So this is xa, ya, which is 1 into 1. So this is xb, yb, which is 2 into 3, 6. So this becomes xy, the limits will go from 1 to 6. So remember, the whole xy is a term. So 6 minus 1, which is 5 joules. Understood what I did? Or if that looks confusing, you can do like this. Integral dxy. You can say put xy is equal to t. Then this will become dt. So ta will be xa ya, which is 1. The limits will be ta is 1. tb will be xb yb, which is 6. So tb will be 6. So the limits will be t will go from 6 to 1, which is 5 joules. There, you can write like that also if that looks confusing. So you cannot integrate x separately, y separately, but together you can integrate it. Is this method clear, everyone? Quite a useful one. Any doubts on method 3? Please ask question 3. So these are called perfect differentials. Now can you do the fourth one? Fourth one is also perfect differential. Let's see whether you can realize how does it look. Siddesh, that's how it looks. Right, Samyak Siddesh, you messed up actually. You got everything, you messed up something. Can you do the D question, everyone? Next class, we'll talk about more about differential functions. Perfect differentials. What if it is not a perfect differential? We will see that in the next class. Right, Siddesh? If it's not a perfect differential, I need more data. You need to tell me what is the path of the equation and all that stuff. We will see that in the next class. But for now, D is a perfect differential. Actually, that is one of the clue in the exam. If you give me some weird function like this, and if you don't tell me the path, that means there's only one way to solve. It's solvable only if it's a perfect differential. Anyone figured out the perfect differential? We have two answers already. Try. I'll give you a minute. D, we have to make it a one term. So what will that be? Two xy cube. Three x square y. So when you see this, you get a feeling 2xy cube dx plus 3x square y square dy. This can be written as y cube 2x dx plus x square 3y square dy. You're seeing something there? This is integral d of x square y cube, isn't it? Check करके देखो. So if you differentiate x square y cube, you get the same thing. So y cube will come out, differentiate x square. X square will come out, differentiate y cube. So you end up with y cube into 2x plus x square into 3y square dy. So that's the same equation there. So there, this is your perfect differential. So this is x square ya cube, which is 1. This is xb square yp cube, that is 2 square, 4 into 27, that's 108. That would be x square y cube. Limits are going from 108 to 1. That's 107 joules. Check. This is also a perfect differential. Right, Anvita. Shman. X square Radite. All clear with this? There. Again, think about it. Today, I didn't teach you anything except integral f bar dot ds. Getting it? We didn't get out of anything other than that one equation. I didn't teach you anything, and we just played around with that only everywhere. There we have done almost 7 questions. The next class, when we catch up, we'll continue with this. We have few more models on work done, and then we will go for potential energy, kinetic energy, definition, and all that stuff. Yeah, you will, like I said, this will be a base chapter. You will see some lot of different things. But quite an important chapter, huh? Quite an important. Just like NLM was a base chapter, work per energy is another base chapter. Okay, with that, we'll wrap up for the day. So I'll see you guys again next week. We'll continue from here. And do remember, this week there's a test online till Saturday night, so make sure to give it. So yeah, any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you guys again next week.